So hopefully you did pause the video and then you went on to the next one, sulfite, an ion. So let's take account to how many valence electrons do we have to work with this time for the Lewis dot structure. Okay, so we have valence electrons for what? Oh, I see sulfur right there. So I'm going to go sulfur. We said 6A on the top has 6. The valence electrons for the O3 that we have right there is 6 times 6. 6 times 3. 6 for each one of the oxygens. You multiply by 3, that's why there's a 3 there. So there's 18 for the oxygen. The sulfur has 6. But notice this one has some extra information. It's telling you you have 2 extra electrons. This one's picked up along the way. Okay, so because we have our 2 minus, we're going to add another 2 right here and take this 26. So we're going to have 26 total valence electrons to work with. Okay, let's put that on this other board. Notice this is the first one to have 3, a subscript of 3. Also, another thing to make sure you're taking into account, there's 1 of these and 3 of these. There's 4 total atoms going on. So don't just think, oh, there's 3 of them, because there's this. Don't forget about the first one, the guy who has a single. Okay, so we're going to go here. There's less sulfur, so sulfur is the middle guy. Surround him with the oxygens. Everybody's going to get 6. And then in a different color, I'm going to bring in green. Green is going to be our extra electrons to join the party. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notice that I don't really follow going around a certain pattern. If I notice that there's one that'll be super beneficial, I know another teacher that I've watched online, he says he was taught to do it a specific way because they'll always face each other. I attempt to get the singles to face in the middle. It doesn't really matter if you just connect the dots. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Another thing you may want to do, notice I didn't like it, they weren't lined up. And also don't make them too teeny tiny. If you need to go like that to make it a little bit thicker, make sure to do so. Okay, before I continue, I'm going to look around. I have 2 more because right now, if you were to count all the little dots, and if you want to, you can pause and do that. What we should have, and to remind you why I know this, it's not just because I know things off the top of my head, 6 plus 18 is 24. If I counted correctly, there should be 24 little blue dots on this whiteboard. Okay? My red 2 that's over there, actually I'll do red 2. I'm going to put 2 more of them. I'm going to pick an oxygen and give it to them. Okay? So I'm going to put one of the new ones right there and one of the new ones down here. Okay, notice there wasn't enough for that guy. There's only 2 to go around. So this is going to make it a little bit more unbalanced. We're not going to be doing the same thing for each oxygen, but that's okay. Okay, connect singles. And again, the oxygens are connecting to that sulfur because it's in the middle. It's the central atom. Okay, so this one goes to that one. And then we're going to see what else can I do. Well, this one can go to that one. But then we have a predicament. There's some singles over here, but how are we going to connect them to other things that are going on? Well, what we're going to do, and notice we come up, we're in a weird situation. There's singles over here, but there's only doubles left to do over here. But when we were doing those diatomic molecules at the beginning, we did have singles, doubles, and triple bonds. There's going to be a double bond going on, meaning, let's take these singles. He can connect to that one, he can connect to that one. Okay, let's clean it up to see if it makes sense, because remember that picture that I showed you at the beginning? I haven't referred to it. Hopefully you remember the thing that I showed you at the beginning. This is our octet rule. Octet means 8. Most of our atoms, most of our elements, they want to have 8 electrons around them, specifically in problems like this. Okay? Because we know we run into problems if we get like more than 8 or less than 8. We're not talking about the smaller elements. Okay, so let's put sulfur in the middle. We'll keep the oxygens here. Okay, this one was only connected with a single, and it had 3 pairs over here. So notice 2, 4, 6. This counts as 2, 8. This guy's happy, he has 8. Okay, he filled up his minivan, okay, or his SUV with 8 people. Down here, we had it connected. This was a single. Notice it's a single going down, and it doesn't matter which one of the oxygens is the one that's going to have the double. Okay, we have that. 2, 4, 6, 8. So these are 2. They're sharing right now. Over here, what we had proposed is, okay, there's going to be a double. Let's do that double thing. And then we have 2 pairs off to the side, like that. Okay, 2, 4, 6, 8. This guy's happy. We haven't accounted for sulfur. Let's see what's going on with sulfur. Remember, each of these lines, the bonds represents 2 of our electrons that are being shared. So 2, 4, 6, 8. He's happy too. He doesn't have any lone pairs. Okay, so it's right there. So this is going to be our Lewis dot structure. What about the VSEPR, those ball and stick things, so I can get a visual 3D model in my head how things would be stuck together. Okay, so sulfur would be right there. These guys are going to split themselves up in a manner that they will be nice and all spread out. Let me see if I can do it. Something like this. Okay, maybe right there. Okay, they're all nice and spread out. And let me actually erase things, because I put it in the wrong spot. I was running out of room. So again, didn't do it on purpose, didn't mess up on purpose. That's to show you, that's why we erase. Do math and science with a pencil. If you're being colorful, scratch it out and do it again. Okay, so I know that the sulfur goes in the middle. What helps me out is that I know what shape I'm supposed to get. Okay, I know it's supposed to be nice and spread out like this. Okay, remember I was pointing out the little number down here, sort of like the opposite exponent thing below the subscript 3. Okay, what shape comes to mind has 3 sides? Triangle. So I knew in my mind this thing better make some kind of triangle, and I wasn't getting it the first try. So then I need to think, how can I split these guys up so that they're spread all apart? It makes this. I'm going to make an adjective trigonal. It's all flat, so it's planar. Like a plane, like in geography, or in geometry, also a plane. So this is more of a 3D thing. This one gives us the info about the valence electron, shows our bonds. Okay. This one we don't really need to show how spread out it is. We just need to show how it's attached. Okay. So notice it's going up in complexity, isn't it? Okay, but hopefully it's still making sense. Again, I'm gonna go and show you, remind you where you should be at on your at-home activity guide right here. Okay, your guided notes. We're gonna be looking to see who turned this in. The more of this you do tomorrow, it's gonna be easier. Because remember, we're doing a flipped lesson. You're learning this stuff at home, and we're gonna practice it in class. You're gonna show off what you learned, okay? So we counted all of our electrons. You should have your Lewis dot structure. Oh, also reflection time. You now have seen how I did it. You get it exactly right. There might be some of you who might have. Nothing worked out for you. I'd be very surprised. I'm pretty sure you did that part right. Okay, I was close, or did you get stuck somewhere along the way? I want you to type directly into this text box. What did you find challenging about this? Was it the little 2 minus thing? Or like me at the end, like, wait, where do you put the double bond? Or, oh, it has to make a triangle? Because you didn't know about that. This is the first one of that shape that we're getting, okay? And then upload your stuff like we've been doing on this home activities. And then, let's go. I think we're going to do one more. This one also has a 3, so we're going to get the same thing. Ammonia. A lot of cleaning things have it. We'll discuss whether they should or shouldn't have it. Okay, let's count up the things. We've done H several times. We know that's 1, okay? We're going to do 1 times 3, that's 3 of them. Periodic table. N, either you count 8, 7, 6, 5. Notice that matches with that 5 right there. So 5 valence electrons. Okay, let's do ammonia. And you're gonna be doing some exploring. I'm gonna leave you to that one because the video isn't gonna follow along. So you're clicking around, get you prepared, being all technological. I want you to be able to use computer stuff, pen and paper, be able to adapt and be all dynamic like that. Whatever you end up doing in the future. And that can switch. You want to stay stuck in something. So got this guy. Let's take into account valence electrons. The central one is the nitrogen because there's more of those. We said this one had 5. Valence electrons for the hydrogen, there's 3 of those. Each one is 1 times 3. So 3 and 5. Add those together. So we're going to get a total of 8 valence electrons, okay? We got room on this one. This one was a little bit cleaner. Okay, so we're going to do nitrogen in the middle. Let's put our hydrogens right here. It looks sort of like the last one, doesn't it? Hydrogen only has 1, 1, 1. This one's 5, so I'm going to do 1, 2, 3, 4, 5. Okay? And then we're going to connect stuff. Well, they made a couple. These 2 are dancing on the dance floor. These 2. These are by themselves. Okay? We did another one where they were by themselves. That was water. Remember that if they're by themselves, there's like a force field right here. All the attractive forces and things repelling each other. Well, these are going to push the thing down and sort of going to pop itself up. It's going to say, I want to be all 3D like. Okay? I'm going to attempt to draw that on the next one. Because sometimes we're going to have other atoms, like we could have, there's something called ammonium, which it has 4 hydrogens. So there would be like the 3 on the bottom and then 1 on the top. So let's see. To show sort of a little bit of the info of the 3D model, we can go like this. Go like this. Go like that. We'll talk about little dashed lines in another case. If you get up to here, I'm good with that. Okay, Lewis dot like that. So this would be like your tripod. You have like a little stool with 3 fingers like this. And notice my hand up here. There's no other finger up here. Up here, this is just like the electron. It's going to do this kind of thing. Meaning nitrogen's right here. That's like the seat of the stool. And you have your hydrogen right here. There's this one. And this one's popping from the back. Okay. This one's also trigonal. That has to do with the triangle. But this one is going to be pyramidal. Meaning like a pyramid. Because if you connected things, you would get a little pyramid, the triangle on the bottom of the base, okay? So again, this would be like our VSEPR thing. And we're going to talk about why the VSEPR, that whole thing of me saying the electrons are pushing it down because they're by themselves on the top. That's an idea from up here. Valence, shell, electron, pair repulsion, okay? And then over here we have our Lewis dot. Let's check our Google Doc to see if we have anything else. And if you went ahead and were actually reading, you would have paused and stuff. If you didn't, that's okay. Either way, I want you to tell me, yes, I did it all by myself, or yes, I get exactly every single thing you did. Seems to make sense. We're all going to need more practice to make it all nice and smoother. Some of you are going to get it right away. You're going to have a chance to show off in more challenging problems. Even if you're not at that level yet, you'll be able to choose these things as well. The technology will hopefully help you. So put right here, what do you find challenging about this problem? Upload your pictures for these 2, your Lewis, your VSEPR thing. And then I want you to visualize how bonding happens. You're going to go to that website. Okay, you're going to pick 5 molecules from the bottom. Okay, and actually I'm going to show a little preview. Let's see why it's not letting me click on things. Let's get it open. Let's do that one. Let me copy it. Tab, just so that you can see the website, so you can know what am I referring to with 5 of them on the bottom. And you should be able to click on it. So you should be on this website. Notice the little thing over here. You click on one, you click on the other one that you want to connect. Remember, the middle one goes to one of the outsides. Click, the thing drags by itself. It took me a while to get that going. Okay? And they have a lot of things going on over here. You can choose from any of the 5 from the bottom. Okay? They're more challenging as you go to the right side, by the way. And don't know why that one's all cut off. Okay? Just pick any 5. Yes, some of them we've already done. And you want to see something that is different from the ones from before. And I'm going to click on that one. And notice if you click on it, it gives you what atoms you're going to have to do. It did the stuff already for the Lewis dot structure. All you're going to do is click. He's in the middle. You're going to connect with that one. Boom. They joined up. There's the couple right there dancing on the dance floor. This one. Boom. And notice how they need to make space on the dance floor. You're not going to dance right next to someone. You're going to step on them and there's issues. Click, and it gets it all together, okay? Just to see, so you can see the finalize, and boom. And that one, it's going to drag it over. And notice how everybody gets himself all nice and spread out on the dance floor. Sketch it out. It doesn't show you like 3D stuff popped up, but this gives you an idea about the Lewis dot structure for things, okay? So you're going to do those. You're going to need to know, like if you did the one I just showed you, I want you to write methane. That's the name of that compound. Here's its chemical formula. You're going to put that right here. Then the ball and stick model, the thing that you saw on the screen, put a little screenshot right there. If you want to draw it out, you can do that as well, for those of you with printers and stuff. And then at the very end, click on this. You're going to have a post evaluation. Don't be scared about evaluation. Want to see if you're awake and you actually watch this. This will be part of your grade, okay? You heard of any of these things? Hopefully yes, because we did all of those. Okay, and then which one's water? Okay, you got some choices right there. Which one's carbon dioxide? About nitrogen? And then we have ammonia. Okay, and I'll see you in class tomorrow, and then we're going to keep on going. You're going to see some other websites. Hopefully you find them interesting. One of them I think is the same one we're doing with the clicking on there. And this concludes your home activities for Vesper and Lewis dot